thanks for coming out this afternoon. My name's Clark Richey, and I am the Chief Technology Officer of a small company called FactGem. Just a little bit about me, most of it's completely irrelevant to why you're here, but that's okay. Mostly I want to give you a brief overview for what this talk is about, so that if it's not what you want to hear, you can quickly run and go see a good talk. I'm going to spend maybe half, maybe a little more than half of the talk in the beginning talking about kind of our technical journey. Where did we start technology-wise? And what changes do we make? What choices do we have to make? What things do we look at that influenced our decision to get to where we are now? So a lot of that's going to be, again, about different databases and different technology we looked at. And then at the end, you're going to kind of get a hodgepodge of some best and maybe worst practices that we discovered along the way in our journey with Neo4j. So it's a bit of a mix-up of sort of different topics all into one talk. So again, if that's not what you want, and other good talks going on. Again, disclaimer. So again, I'm going to talk about a bunch of different databases. These evaluations were conducted roughly in the summer of 2014. And things, of course, have changed in the roughly 18 months or so since then. I'll talk a little bit about what seems to have changed in this space in that time. But again, I did not go back for this talk and do the entire analysis all over again because I still have a job and I have to do that. So, and again, and your mileage may vary. We picked the technology that met our needs at the moment and that continue to meet our needs. They may or may not be your needs. But again, hopefully it'll give you some insight into, if you look in graph databases, into what things you might want to take advantage of or look at in your journey. And then if you do end up on Neo, hopefully some good information on things to avoid or think about or to do maybe in a better way. One of the things I'm not going to do, by the way, is I'm not going to show you our application. I'm not going to talk about it really at all. Other than in the very large sense, this actually made my UX designer very, very sad. He asked me like 4 times, you're going to show the app, right? I said, no, I'm not showing the app. He's like, oh, okay. But I still love the app. It's not that talk. And I'm happy to show anyone the app later if they want to talk about it. This isn't that talk. You don't care about my app. I've done these things a lot before. You don't care about what I sell. That's okay. That's not about what we're here to do. So in the beginning, right, we kind of had this vision. And what our founder's vision really was about was, wouldn't it be great, she had this problem originally of having lots and lots of different files, thousands of different files, Excel spreadsheets and things, and had to make these decisions on them, right, for her business. And it was really just this horrendous process of opening up a bunch of Excel files over here and some other ones over here and some documents and changing back and forth because they're all in different places and you can't search them, right? We've all sort of been there. So wouldn't it be great if we could bring them all into one spot and I could search them and do some stuff? Like that would be really cool. She thought. I said, yeah, that would be cool. Let's bring in all different kinds of data formats into one place. Let's do some analysis on it, let you search on them, maybe do some visualization. And that was sort of our initial vision for this. And we thought about this. The first thing we realized is, well, an RDB message is not going to do it, right? Again, if we'd actually gone to the first slide, at the time I was working for a company called MarkLogic, which happens to be a sort of local to the Bay Area enterprise database company. We'll talk more about them in some slides. But the good part was I had some foundation now in NoSQL technologies, right? For the vast majority of my career, probably like most people in the industry, I had built applications on relational databases. That's just what you did, right, for forever. You didn't even think about what database you were going to use, except that like whether you use Oracle or maybe something else and how much budget you have. It was just taken for granted for the vast majority of time. It was going to be an RDBMS. But RDBMSs, right, require a fixed schema. So here's a very simple one, right? But you have to know this ahead of time. You've got to create the tables. You've got to identify the relationships, the joins, and all of that. And we need something flexible. Right? The idea was bring in all kinds of different data sort of at runtime. And so this we knew just wouldn't cut it. We had something that would definitely be more flexible than the relational model. So we started at home. As I said, I worked with for MarkLogic at the time. Here's a little bit about it. It's, I call it an enterprise-grade schema-free XML database. It's more than that, right? It's also a document database. It does JSON now and some other things. But again, I'm not here to go into great details in all these other database systems. It's not that tutorial. But things we loved about it, and I still do, is very fast loading. You can load data, information really, really fast into it. And that seems like a good thing. Create all different kinds of files, and I wanted to obviously load them quickly. I don't think anyone ever says, let's load stuff slowly. That would be cool. So that was good. And we want to search fast. Again, I don't want to search slow, but it had really good searching very, very quickly. I could find the documents that had these 4 or 5 properties and different ranges and some full text, and it would happen really fast. And I knew this. I've been using this product for 5 years. So that was great. I can do faster navigation. And I do have, and against a NoSQL database that's schema-free, I can add information that I hadn't seen before. So super. This is absolutely where we're going to start. And so we did, and we did sort of this initial POC, and things were really, really good. But we learned some stuff from that POC, right? As one typically does, right? You do a proof of concept and say, this is great, this works. But a proof of concept, by definition, right, it's a limited vision, right? We took a sort of subset of the grand vision, and we said, well, we can't do everything at once. We just want to see if this works. Could we do this? So we took some sample sets, and still a good bit of data, and we were able to do all the things we talked about, fast searching and faster navigation, and that was really good. We liked that a lot. We were kind of happy, kind of like this guy. I don't know what this is he's doing, but it looked cool, so that's kind of what went with the picture, by the way. That guy doesn't actually work with us, but he seems happy. And again, so we sort of climbed this mountain of this POC, and we got some more insight. And what we realized was while the information in the documents at the time, we were modeling our information in documents, was really interesting. We get some good insights off of them. What seemed to be more interesting to us was the relationship that was implicit between the documents. So that if we could really exploit that, that would be even cooler than what we're doing now. And we thought what we were doing was pretty cool to begin with. We thought this could be even cooler. So let's figure out if we can actually change the system and deal more with the relationships and explore that space. And we tried that a little bit, but didn't really fit with what we were doing at the time. Again, we were modeling our databases, or rather our information as documents, in a database that was really great for that. But when you're working with a document database, what's it really care about? Of course, well, documents. Now, can you do joins and relationships? Absolutely. We could, and we did. But it wasn't its strength, right? You could certainly do 1 or 2 hop joins. We just want to go 3 and 4 and 5 hops and do lots of these big data sets. It just wasn't ideal, right? We could do very fast searches within the documents. We could do really complicated search within the documents. But searching between relationships, again, we were using it not for exactly what it was intended for. And that's a theme you're going to hear me talk about a lot, is sort of understanding what it is you want to do, using the right tool for the right job, right? Not a new concept, not something specific to graph databases, but something that's certainly important. So as we looked at that, we certainly didn't give up, and we loved MarkLogic. We still do. And MarkLogic did something really cool at the time. This was, like 18 months ago maybe. And it added support for RDF. Who here is familiar with RDF? Anybody? I know one guy. I know you are. Yeah. Cool. So RDF is this resource description framework. Another quick disclaimer: this is not going to be an RDF tutorial. That's like another 2-hour talk, and I'm not going to give it. But RDF basically, well, another slide talks about what RDF is. But so we migrated all of our information that was currently before stored and represented in XML in documents. So we're going to move that to RDF. It's a big move. It's a very different way of looking at data. But we said this is the right thing. We really believe this is the right thing. Fortunately, it wasn't that hard to do because we did decouple. We were very deliberate to decouple our persistence layer from sort of the rest of the architecture. I know that's something you've probably heard for years, but it really matters, obviously. So it was still about probably 2 months worth of work, but we were able to do it without it impacting the rest of the application tremendously. So why RDF? Why did RDF make us excited at the time? Well, RDF was really sort of designed, and there's your sort of starting point for where to go to start learning about RDF if you're so inclined, is really designed about linking information, right? And it uses URIs, Uniform Resource Identifiers, to link information together. So we said, great, this is good. Here's a format specifically designed around links. We think links really are the key. Let's go with this. And there's actually been a lot of work, for many, many, many years done on RDF. And there's a standard way of querying RDF, which is Sparkle. And we thought that's great too, right? If we have a standard query language, we get some vendor independence, right? And that seems like a good thing, especially since we haven't changed vendors, but we've sort of changed our database. And what if we have to do that again? It'd be great if we could use a standard query language. And so very briefly, RDF is about subject, predicate, object relationships. So you can sort of see them, very simply modeled here. Here's a little better example. So if I want to say that, and this became awkward, so John used to be the head of support here at NEO. He's recently left, so awkward slide. But so if I want to say John Clark knows John Forrest, you basically have this resource in RDF. We call it Clark, and we have some properties on it, maybe in this case a given name, surname is of type of person, and you have sort of the same thing for John, and then you have this sort of relationship between nodes, nodes relationship between the two of them. So it's a very nice picture, right? And you can kind of look at it, and maybe it seems a little odd that things are, like the name is broken out differently, but that's fine. This is, again, a basic sort of pictograph of the RDF concept. There's lots of ways of representing RDF. This is just one of them. These are some RDF triples that basically represent what I showed you in the picture before. It's probably a little bit hard to read in the back. I apologize. Again, point here being, again, there are many ways of doing it. There's turtle and a good half dozen ways of doing this. This is one. It can be a little bit verbose. But again, we had a really powerful database. We weren't really worried about that. And so it shows you what things, how they sort of start to break down with identifiers, again, for the resource. So that's the subject. Here's the predicate in this case, and this is the type, and back to an object, and so on. So that was good. We liked RDF. There's a lot we actually really liked. So we rebuilt sort of the whole POC using RDF, and it solved a bunch of problems. We were now able to do more. We would be able to explore more relationships and see more things. But it wasn't a great fit for us. It kind of made us a little sad. And again, if someone here loves RDF, that's great. I'm not here knocking RDF, but doing RDF felt a little bit like joining a cult, honestly, if I can be honest with you. It really did. People out there are very, very passionate about RDF. It's very big in academic circles and some other areas. And once you sort of delve into that discussion, everybody has like the standard that they love. And if you're not doing their standard, you might as well just die. I mean, it's like religious wars, right? And we weren't really into that, right? Now, those standards have their place, right? If your application is all about really sharing data on a large scale amongst different organizations, different industries and things, those kinds of standards can be very important. That's not what we were focused on. So we didn't want to sort of get into that game. And as you see, RDF is very verbose, right? It's basically this non-properties-based graph. So everything is a node. So you have a lot of nodes. And so when you want to do very, very complex sort of queries of the relationship between things, there's a lot of things you've got to kind of walk and then join on and walk back. And that didn't really get us where we needed to go. That sort of intrinsic nature of RDF and Sparkle caused us some performance issues that we weren't really thrilled with. And again, really, it was about the nature of sort of that tech, RDF, Sparkle, more than really anything else. But it did help us sort of see the possibilities inherent in focusing on these relationships. We really enjoyed that. So we knew we liked linked data. This is definitely where we wanted to go. We just didn't want to get there with RDF. So we didn't give up, fortunately. We were kind of upset, a little concerned, because now we're saying, well, we've changed data formats at least once. We're a small startup. We're now thinking we need maybe a completely new database. So it's like, Is it another 3 months? What's this going to be? We're really hurting to do something. But again, my point here is it's hard when you're a startup, certainly, or at any time, but I really feel it's important to try to make the right choice. Right? A lot of times when you're building something, you come to a choice and you're like, wow, this isn't perfect. And I think I can make it better. And there's a lot of pressure, right, to just stay with what you do. You got to make it work, man. You got a deadline. You've got to make it work. But sometimes you just have to know, like, this isn't going to get you there, and you got to change now. I mean, I know it's easier said than done, right? But we did it. We're very happy we did it. And what we realized, again, was we thought a lot about RDF and what it gave us. And just doing some research, said, whoa, there's this other thing out there called these graph databases. I'm like, well, I must just make RDF. We looked at other databases that did RDF, like Allegra Graph and some other things, and again, didn't really get there for us. So, but one of the things that kind of bothered us was, interesting. This is really kind of complicated. Like, just to say there's these two guys that know each other and they've got a name, that's a lot of stuff. So of course there's overhead. Really, I just sort of want to have this. I want to have a graph where I can say in the node, like this resource, this node, or whatever, has a first name and a last name, and so does this one. And then there's just two things in a line. That seems like it'd be more efficient. And we sort of discovered that, well, that's a properties-based graph. So, wow, this could be very exciting. And again, if this properties-based graph and something that actually knew about relationships as a top-level thing, that would be great. Again, we realized you can't do it in a relational database. Why? Well, ironically, as most of you are probably aware, relational databases at a certain number of relationships don't do relationships well. So the great irony of relational databases, right? They don't do relations well. And if you go back to sort of our original picture, which I won't flip to, saw all those lines between the tables? Well, those aren't real, right? They're not real concrete sort of things. They're all, foreign keys in other tables and then joins and indexes. They're just sort of pictures we put on paper to make us understand things better. They're not real concrete things like they are in Neo or in a graph where you can grab the relationship. So we knew we couldn't go back to relational. So we started looking at graph databases. And there's two I'm going to talk about. The first one that we saw was Titan DB. And Titan was very exciting to us at first. It really was. It had a very powerful feature set. I'd arguably say the most powerful feature set of anything we looked at. It had extreme scalability. I think at the page at the time, it was some number of quintillion. There's a hard limit, like some number of quintillion nodes. I mean, it was something stupidly high, right? But that seemed cool. Right? It was really scalable. Unfortunately, it was really kind of complex to get started. So at the time, you had to run it off of either a Cassandra or an H-based backend. Okay, both Cassandra and H-based are very powerful, very scalable tools, but it's not like the easiest thing in the world to get started. If you've never done Cassandra or H-based, just go, oh, I'll just stand up a Cassandra or an H-based cluster, and then I'll stand up something on top of it, and like, wow, you're in a whole other realm of complexity. The other thing that really concerned me about it, again, is they were eventually consistent stores, right? These were not ACID-compliant stores. They actually were very clear, and I appreciate the time, on their site saying, if you do run the big graph database here on Titan for a long period of time, it's going to become inconsistent. They straight up told you that. It will become inconsistent. And it was in the facts page. It's gone now. But it's in the FAQ page. And the way they had to deal with that was there's this whole other project called, I think it was Fanix or something like that with an F. And it was basically a long-running process that constantly walked the entire graph. And then you could configure it in a certain way to detect inconsistencies and maybe sort of fix it. That really didn't seem cool. And again, the other thing that made me nervous is this was something that was taking a graph concept and applying that as a layer on top of a native store that wasn't graph-based. So Cassandra and H-based are not graph-based, not at all. And now they actually do support, I think, Berkeley DB as well, which, again, not graph-based. So, I've been doing this NoSQL stuff for a while, databases. That made me really nervous. So we moved on. Looked at Orion DB. Orion DB seemed cool. It seemed much easier to start with. Had a lot of features as well. And a lot of those features were sort of document-centric features. And again, I came from a strong background of a document database, and I kind of liked that, and I was familiar with that, and that seemed good. Performance and scalability seemed to be a concern, mostly from some anecdotal discussions I had with people who've been using it and some things I've read in the forums. Also, again, at the time at least, they were very focused on saying they were this multimodal database, right? We're a graph database, but we're also a document database. We kind of have the SQL thing on the side. And again, it really concerned me. I wanted to just do graphs and do graphs well. So that was my biggest concern really there. So we moved away from Orion DB again because of its sort of lack of focus at the time on pure graph operations. And we found Neo. And I'll be honest, I had a lot of friends in the community who said, oh, we've tried Neo and it's slow. We use Titan. I said, okay, all right, well, I'm going to try it anyway. Because I tried Titan too, and yeah, it seemed pretty fast, but like, you guys have talked, like, they were big, like, Cassandra and HBase and open source guys, and like just really into that space. Sort of came out of the Hadoop world, and I get that, but I wasn't really a huge fan of that. I didn't dislike it, but I wasn't really into that. So I'm going to try Neo. And it was highly scalable, right? And it had some hard limit too, which was not like 15 quintillion, but it was still some number that was way higher than anything I was worried about. And it was really easy to get started. Like, that was a huge deal for us, especially when you're at this point when you're when you're changing databases again for essentially the third time. You got to get going fast, right? The performance was good. It was really good. It was way better than my friends told me it was going to be. The documentation was very extensive, especially with something that is primarily open source. I mean, we all know how good open source docs tend to be, right? And the feature set was adequate. And I don't mean this as a negative, right? Again, sometimes when the feature is too big, it gets a bit overwhelming, right? And at least it gives me sometimes a little concern, you know, like with Orient, lots of features, document features, and this over here. Are you really focused on my use case? And on the Neo4j features, really, we're focused on the graph use case. I mean, honestly, the only feature that really almost tipped us back to Titan anyway was their support for maps as a native node type. Because that's just obviously a very powerful thing. But we said, OK, you know what? We can get by without it. We'd still love to have maps, but we can get by without it. It's a whole other conversation. But it's been great, OK? So we got to Neo. We've been on Neo for about 16 months or so now on the enterprise version. And honestly, it has been fantastic. It was easy to use, easy to set up, maintain, and it delivered or exceeded really all of our expectations for what we needed to do. So it enabled us to get beyond our POC, to get into production, to build new things very, very, very quickly. And that's been just fantastic. So now I'm going to transition into the portion of the talk where we talk a little bit about what did we learn once we made the transition to Neo. We're a Java shop. We're primarily Java and actually mostly Groovy at this point, so which is another reason why Neo was great for us, being a native Java platform. We run Neo4j embedded. We didn't initially do that because we didn't fully understand initially how that worked, but then we kind of got a little bit of training and said, oh, I don't have to make these like REST calls and I can do that. Well, that's great because I have no intention of exposing my database to the outside world via REST. It actually scares me a lot. It really gives me nightmares, actually. This is a great link. This is a talk given at Java 1, I want to say last year, actually, on REST security vulnerabilities, which is really very frightening. And I'm not going to go into it here, but exposing any database to the outside world directly via REST, I think, is a horrendously bad idea. Exposing internally, sure. I mean, there are reasons to do that, but you still have to be super careful because if someone gets past your internal, that other firewall, and can get to the database via REST, you can have troubles. So reduce complexity for us running embedded. We could directly call out to the Neo API in process, and we have a lot of Java experience in the team, and at the time, of course, zero Cypher experience, and we're way behind the 8 ball. So we said, I can get going very quickly by using the Java API. It's not maybe the simplest thing in the world, but we were able to learn it quickly and get great performance out of it. And we didn't need to do extensions either, so no managed or unmanaged extensions because we're just running it in process. And it allowed us to use, and still does, any combination of Cypher and the Java API depending upon our particular need at the moment. So again, I'm a huge proponent of running it embedded. And definitely looking forward to the new language drivers. So my second tip is you really have to understand your strengths, right? This certainly applied to when we were looking at different databases, and even then once you choose, right? And again, this isn't unique to a graph, right? But you have to understand, you picked a tool, you really understand what it's good at. If you try to use it for the wrong thing, don't complain that it doesn't do that well, because that's not what it does. Right? Native graph databases are really, really good with relationships. You find a starting point in that graph and you want to walk it as deep as you want, it is blazing fast in Neo. Blazing fast. If you want to do things that it doesn't do well, of course, if you want to do complex, full text search and multi-valued property searches off a single node, you could do that, but that's not what you bought a graph database for, right? I actually recently just had a prospective customer ask us how we deal with many-to-many relationships. I'm like, really? That's great. That's what we do. It's a graph. It's all about many-to-many relationships. It's not even a hurdle anymore, right? But people are so used to that kind of pain point. The other thing you have to understand, and this is a vast simplification. I should actually put that as a watermark on here, right? Vast simplification. What happens when you query? You've got to kind of understand, and there was a really good talk downstairs just a little while ago on how to optimize your cipher and so on. But here's a sample query, right? I'm going to find some person who has a license, and that person also has some residential address to place, and I want to find out whether that person is male, and the license type is a hunting license, and the county is Franklin, right? So I've got basically a person node connected to a license node, and they're also connected to a place node, and I've got different properties on each node, and I want to find the result of those things. Okay, vast simplification, but the first thing the database needs to do is find the starting point. Where do I start? I'm a graph database. Where do I start walking this graph? And once I find that, then I can walk the graph out from there. Right? It might be multiple places I have to start with, but then I can walk the graph from there. And finding the start is very, very often the pain point. Okay? This thing to be very cognizant of. So originally there still is a rule-based planner that was really just designed prior to 2.2, and it really just looked at a bunch of preset rules for determining where do I start. And it used the indexes that were there, but it was just a set of static rules. Now with 2.2, for all your read operations by default, there's this cost-based planner, right, which uses some statistics that Neo keeps on the database and on the indexes to help determine where to start. But it's not perfect. It's actually very new. It's a huge step in the right direction, but it's definitely not perfect. So let's talk about indexes. Indexes are really just duplicate bits of information in the database that help it rapidly find nodes. And really, in this case, it's only used for finding out where do you start. Where do I start walking my graph? You don't have to have indexes to do this, but they are very, very helpful. We have lots of indexes, and my general rule is if you're going to be searching on something and that property is something you're going to be searching on of a node, put an index on it, because otherwise you're going to hit some pain. But it does increase your size on disk. Indexes take up room on disk. They are duplicate bits of information. So there's two types of indexes, right? The schema indexes. That's the newest flavor. They use some internal custom Neo4j indexing that is built in-house. And they are currently, again, the default indexes used by Cipher and the cost planner. And the really nice things about these is once you create them, either via Cipher or the Java API, they're automatically maintained by the database. So as soon as you say, I want to create an index on every node with the label person and the property gender. So index for me, the gender property of people nodes. If I create a new node, if I change the value of a node, if I delete a node, I don't have to worry about the indexes. Neo just maintains them and updates them for me appropriately. And that's really nice. You also now can have constraints on them, like this property must be unique or must exist. And there's more coming, I understand, in 3.0. So then there's legacy indexes. Legacy is a really lousy term. I don't know who came up with that at Neo. I think everyone regrets it, though. And really, the legacy indexes are the Lucene indexes. The older ones, they're not deprecated. My understanding is they're not going to be removed anytime really soon. So again, legacy, maybe not a great term. These can be configured, again, either via a configuration file, your Neo properties file, or via the Java API, or I think via Cypher, actually, as well. And the legacy indexes don't use that proprietary Neo4j indexing mechanism. They use Lucene. And they use Lucene right now, at least as of 3.62. I don't know in 3. I don't think it's a major change. I think it's still something in that 3 range. Be aware, current Lucene is 5.3.1. There's a huge world of difference between Lucene 5.3.1 and Lucene 3.6. Okay? So my word of caution is very strong is be very cautious in how you use them. I will say that we have not had very many bugs we found with Neo, but every time we've either had some bug we've actually hit that was an actual bug or hit some weird problem, 99 times out of 100, it was related to the legacy indexes and how Lucene does things. Again, it's a very old version of Lucene. However, though, sometimes you do need these indexes, and we'll talk about that in a second. Star Wars was just announced, right? Again, the last trailer, so I had a little Star Wars reference. Apache Luke is actually there for you. Use the Force, Luke. That's what it's there for. That's the way you laugh. It's fine, whatever, I don't care. No. So Apache Luke is a great tool. It's an open source tool. You go ahead and download it. It's a little Java jar. And it lets you directly view and search the Lucene indexes. This has come in very handy when we saw sometimes odd behavior in our indexes, either cases where like we're searching something and it just doesn't come back right, and we're using the legacy indexes, or they seem to maybe be corrupted to actually be able to go in, directly look at the indexes and see like, oh, well, I just didn't do something right. It's not being indexed that way, or maybe there actually is a problem with the Lucene index. And so there's two types of ways of dealing with the legacy indexes. There's auto-indexing and there's sort of manual indexing. I would recommend, again, use auto-indexing if you can get away with it. Why? It's easier to maintain, right? It's auto-indexing. Basically, you set it up once in the configuration file, again, or through the API, and then you tell it similar to the schema index, hey, I want to index this property on this type of node, and then it just maintains it for you. You don't have to worry about it. However, and this is why we end up not using them, you don't specify the auto index for the legacy indexing what type of index it is. Right, so Lucene, so it doesn't apply to the new schema indexes, but in Lucene has different index types, like there's some for string, some things that are case sensitive, that are case insensitive, for things that are numeric, and they're actually physically separate indexes. And when you query Lucene, and you want to use those indexes, the first thing you have to do is tell Lucene which index to use. It makes a difference in how things are sorted and compared and so on. And when you do auto-indexing, Neo tries to get smart about which index it should use. So it looks at basically the first thing you index. It goes, oh, blue. Well, blue's a string. I'm going to put this in the string index, and now and forevermore, that property index goes into is considered a Lucene string index, which is fine very often if you've got really good control of the data coming in, right? Our system does not. We accept data from all different sources, and a lot of it is dirty. So that blue property that came in may have came in for your age. Well, okay, that's, I can see that can happen. But now, if that's the first thing that came in, it's going to index age as a string-based thing, not a numeric. And now my comparisons and things, and my ranges don't work the way I want them to work because it's a string-based index. So if that's something you have to deal with, where the data might be unclean in that sense, then you've got to manually index it. Because then when you manually create the indexes, you can tell Neo, oh, this is going to be a case-insensitive numeric, or whatever the case might actually be. The other nice thing, too, is you can read, if you do auto-indexing and something does go bad with Lucene indexes, you can really, it's one of those like buyer beware things, right? Like if things like really go bad on you and those have gotten corrupted somehow, you can kind of stop the whole database. You can go into the Lucene index directory. You can delete it, restart the database, and Neo will re-index all the nodes. If you are doing that manually, that doesn't happen automatically because they're manually indexed. You've now got to write some process, right, to go back and touch all the nodes and re-index them. So I had this really cool couple slides in here about range queries, and I kind of showed the code It seemed really technical, and then they released 2.3 and kind of ruined everything. But I'm still going to talk about these two slides because I suspect not everyone here is on 2.3 yet, right? It was out 4 hours ago. We changed. No? Okay. And some people probably won't move that fast anyway. So I'm going to show you the slides anyway. So here's a very simple query, right? I put the word profile in front because I want to see the query profile. And I'm just going to find all people that have an income. Hello. There we go. I get the hook. So they have an income of a certain value, and it's going to bring back the first two. And I really only run this query to show you that I actually have an index on income for a person. Right? It's sort of the nothing up my sleeve query. So you see, here's the planner, and it does a limit. So they say I have a limit on my thing of only 2, and it does that node index seek, right? So that's using the index, and it's using the index to look up that value. And we can see here it hits roughly 2,800 database accesses. I've got over 220,000 people in the sample database. So that's pretty good. You do a range query, and so now it's saying less than 50,000. You'll notice now it does a node by label scan. And I'm up to 430,000 database hits because it doesn't use the index. Prior to 2.3, this changed in 2.3. Prior to 2.3, the schema indexes didn't support ranges. So you had to use a legacy index and directly query the Lucene index for it to work. But of course, now 2.3 is out, and this will work in 2.3, which kind of ruined my slides. But I don't like to be defeated, so I threw a slide in at the last minute. And now this is actually running with 2.3. And if you run with 2.3, you do see now you do get a node index seek by range, and you're down to 3 database accesses. So yay 2.3, you get range indexes on schema labels. Real quickly, I guess I'm running out of time here. So node IDs, don't use the internal node ID. There's a good link to some posts in the documentation where they tell you again not to do that. Current node IDs are long. It's super tempting to use them. I did it first. It's a bad idea. You think like, oh, I'm never going to delete things from my database or whatever. Yeah, but you do. So basically what happens again is Neo uses a long, it increments as it goes on. If you delete a node, eventually once they sort of flip over the index, the node IDs rather, it can reuse the numbers, so you don't want to be handing those out. Lots of other good ways to do them. We basically use a combination of the node label plus a randomized UUID. The other nice thing I like is, again, if you start exposing your API externally, people start seeing, oh, your IDs of things are just numbers. I can start guessing IDs. I can start guessing numbers. Have fun guessing my 64-bit UUIDs. Again, modeling. Modeling is at least as important as your queries. 3 really good links here to tutorials on that. One of the key ones I'll talk a little bit about is relationships versus properties. Lots of ways to do this, right? Sometimes you can model a relationship by putting a property on a relationship, or maybe using multiple relationship types. Both seem very reasonable. Performances can vary significantly, and that link gives you all the numbers on it. But very quickly, it's the difference between saying, for example, a person in a place relationship has address, and you put a type property on it. So I can say it's the work address, or the residential address, or the mailing address. It seems very reasonable to do, and you can certainly do that. Versus saying, really, there's 3 different types of properties. Has residential address, has mailing, or has residential address a second time, I guess, or third time. The performance increase can be 8x or faster, really, in terms of actually having to traverse now those relationships. Again, so not to say you should never use the types, but again, read the article there. It goes into it much better. Performance, again, explain and profile are definitely your friends. Don't be afraid of the Java API. The query planner is still very young and can be faster than the Cypher in a lot of situations. When you're benchmarking, again, always benchmark against a warm database. That's your typical production profile. You're typically not ever the first user to run a query ever in the database. So warm the database, let Neo do its thing with its caches, then actually run your benchmarks. And really just communicate, right? Neo's got great community support. It's got a Google Groups. It's got a Slack channel. It's Stack Overflow. And honestly, Neo4j support has been terrific. I really couldn't say better things about them. And this is your last bonus slide, because I stuck it at the last. Keep this code in your toolbox. Not that you'll ever do anything weird with your database and go, oh my gosh, I need to fix that. This is basically boilerplate code for going through every node in your database and fixing stuff. So here I'm grabbing relationships. You might want to you could grab nodes instead, or you could grab some qualification. But basically it lets you loop through all the nodes in your database transactionally. Here it's 90,000, basically 90,000 operations per transaction, and sort of batch change the entire database if you need to. Yes, it can run a little bit, but I've had to do this, unfortunately, far more than once. So bonus slide. OK, and I'm way out of time. So questions or thoughts?
Oh, great talk. Two quick questions. Going back on your point about the starting node being the pain point. I mean, is that to imply that you should do everything that you can in the query to try to restrict and use the indexes, whatnot, to reduce the number? Yeah.
So we do a lot of things, even design-wise, to try to prevent users from doing really, really broad searches at first. Find me people who live in California. Oh, bad. And to narrow them down. There's also, again, a lot of work being done into the cost planner still. And again, I say, if you find queries that don't perform the way you should, or you think they should, profile them, communicate that back to support, and they are really looking for that kind of data to make the planner better.
Yeah, and the second part of the question is, you're in production 18 months. I wonder if you're running on a cluster. If so, how many nodes, and what experience could you share on that?
So we're not yet running on a cluster. Size-wise, we just haven't needed a larger cluster. And honestly, from the HA point of view, it just hasn't been an issue for us yet. So we are doing automated backups every night. But at this current point, we're not actually running on the cluster.
When you were talking about RDF, you mentioned verboseness is one of the weaknesses of RDF. Is there any other reason that you ditched RDF?
That was so why we ditched RDF? It was really verboseness. Essentially, and it's not purely just RDF. It was, if you want to generalize that more a little bit, it was RDF as an implementation of a non-properties-based graph, right? So again, if I don't let you put any properties on a node of a relationship, then everything has to become another node and another relationship, and it's just more stuff you have to do, more work that has to happen by whatever engine is running it, and that just really was the pain point for us. Cool. All right. Well, thank you very much.